topics. This will not cover all the topics of this of the midterm. So in the midterm, you may see some other types of problems which are not covered in this review, I would say. Sınav kaç dakika olacak? Bunun duyurusunu yapmıştık galiba. 20-20, arada 10 dakika var. 20'şer dakika 2 session halinde.
Günaydın hocam. Bir şey sorabilir miyim?
Tabii.
Ya hani biz matrixlerde bulup E üzeri değer yazıyorduk ya.
Evet.
Bir de onun sinli ve cos'lu formüllerini de yaptık ya. Onlardan sorumlu değiliz değil mi? Sadece E
Yok.
üzeri yazmaktan sorumlu. Tamam, teşekkür ederim.
Hatta o bile sayılmaz. Yani ona bile çok gerek yok. Çünkü reel durumda zaten onu kullanmadan da çözebiliyoruz.
Aha, tamam.
Dolayısıyla evet, bu sınavda dahil değil.
Teşekkür ederim hocam.
Rica ederim. Bir çözüm kağıdını yükleyeceğiz mi diye sormuşsunuz. Yok, çözüm kağıtlarını yüklemiyorsunuz. Karalama kağıtları sizde kalıyor. Yani sınav işte aynen şeydeki gibi. Şu an bir mock exam vardı. ODTÜ Class'ta yaptıysanız aynen onun gibi olacak. Yani şıklı ya da cevap yazacaksınız oraya. Well, okay, then let's start our review. Okay, record this. All right, this is review for the midterm one. Let's start with this problem. Let's solve this equation t y prime plus 2y is equal to sine t. Well, to solve this, first we need to understand the type of this equation. It's a first order equation and it is linear because you can write this as the following: y prime, you divide everything by t and it becomes 2 over t y is equal to sine t over t. Now, this is a linear equation. Remember, this is your p and this is your q in the first order linear equation. And integrating factor is simply mu of t e to the integral p of t dt. So it's 2 dt, 2 over 2 dt over t. 2 dt over t. Okay. Well, let's compute this. It's e to the 2 ln t. Well, this is basically t squared. So this is my integrating factor, and let's put this back in here equation. Okay, so the equation becomes the following. You multiply both sides with t squared times y, derivative of this. It becomes basically sine t times sine t, right? You multiply both sides with t squared and you get this. Well, this implies t squared y is equal to integral t times sine t dt. And to find this integral, we will do integration by part. Let's say this is u, this is dv. So the resulting integral will be u times v, which is t times minus cosine t minus v times du, which is dt. Okay, and this is nothing but minus t cosine t plus cosine t. Integral of cosine t is sine t plus a constant. So from this, we can write y explicit. Y is equal to minus t cosine t plus sine t plus c over t squared. Okay, so this is the answer. So this is the general solution of the equation. Any question with this? Is it clear for all?
Hocam,
Evet.
could you repeat the part after we have found the integrating factor, please?
Well,
what was that equation?
Well, once you find this integrating factor, this becomes that one. Okay, so basically, if you expand this, what is this here? It's t squared times y prime t plus 2t y, right? And this is nothing but you multiply the whole thing here by t squared, right? So when you multiply this with t squared, multiply with t squared, you get that, right? Clear now?
Yes, thanks a lot.
Okay. Any other question? We do this automatic because it's always same. So when you have the integrating factor, you always have like integrating factor times y, the derivative of this thing here, mu of t times y is equal to right hand side times mu of t. Okay, you always get this. You don't have to check every time. Okay, question, comment? Okay, well, let's do another one. Now let's solve t cube y prime plus 4t y is equal to e, and this is an initial value problem, IVP. At -1 we have 0. Okay, so let us solve this. Well, again, this is this can be done in the previous way. It's a first order linear equation. So let's write it in the linear form. Y prime plus 4 over t squared y is equal to e over t cubed, right? So it's a linear equation, first order linear equation. And again, 4 over t squared is, this is p, okay? So we can find the integrating factor, mu of t, which is e to the integral 4 dt over t square. Well, this is basically e to the minus 4 t to the minus 1. Okay, good. Let's multiply both sides with this integrating factor. So the equation becomes here d dt of e to the minus 4. Let's write it like this, minus 4 over t times y is equal to e to the minus 4 over t times e over t cube. Okay, this. Okay, then let's integrate this. So we get basically e to the minus 4 over t times y is equal to the integral. You can take this e out, one of the e out, e integral e to the minus, oh, that's not very easy. But maybe let me modify this problem because this integration will be difficult to handle. Okay, maybe let's modify this and solve this one. Et, let's say, here. So this becomes t square here instead of t cube. Okay. T square here. You can also do in the previous one, but it's going to be longer, so let's not do it. 4 over t over t square dt. Now this integral, you can do it with substitution. Say, for instance, u is equal to minus 1 over t. Then du becomes 1 over t square dt, which is in the integral. So then this integral here becomes basically integral e to the 4u du. Okay, so from this e to the minus 4 over t times y is equal to e times e to the 4u over 4. But u was minus 1 over t, okay? Plus a constant. Well, we can handle this with the initial value. So what is y here? What is c here? Maybe let's write first y. Y is equal to e times, it's like the, of course, with parentheses. Not very important because the parentheses is not important here because e times c is a constant as again, so you will get a constant anyway, but let's write like this. E to the 4 over t times e, which is plus 1 here, times 4 over t here. It's better. Okay, let's write. Clear. 4 over t plus 1. Okay, times e to the minus 1 over t over 4 plus c. Well, at minus 1, it was 0. When you plug minus 1 here, y minus 1, it's e to the minus 3 times e over 4 plus c is equal to 0, which implies basically, since e to the minus 3 is non-zero, this is never 0, that means the c must be minus e over 4. Then you plug this back in here, so y is equal to e to the 4 over t plus 1 times e to the minus 1 over t minus e over 4. Right. We made a mistake here. Thanks for this. This should be okay. E to the 4 u over 4, right? 4u, 4 times this. Okay, this should be 4, right? Yeah. This should be 4, so this should be 4. And at minus 1, it's going to be e to the 4 here, right? Minus e to the 4 here. And here and here. Okay, yeah. Thanks for correcting this. Yeah. Any other question, comment? All right, let's do another example. Let us solve dy dx is equal to 4y plus x over 2x. So what type is this equation? Any guess?
Separable.
Separable? It's not separable.
Homogeneous hocam.
Okay, it's homogeneous, right? You can check this when you replace lambda x by lambda x and y by lambda y, this will stay same. Okay, so when you multiply x and y with lambda, any lambda, you will get the same function. That means it's a homogeneous equation. Okay. This is homogeneous. Let's say this is f of x, y, since maybe let's write it here. Let's call it star here. So star is homogeneous. Since f of lambda x lambda y is equal to f of xy for any lambda real. Okay. You can see from the equation. Well, in that case, we will write this equation. On the right hand side, we will have a function of y over x. So you can write like this: 2 times y over x plus x over 2x, which is 1 over 2. Okay. It is the same, right? This is against star. Well, let's say y over x is v. Okay, so y is equal to x times v, then y prime is equal to x times v prime plus v. Okay, derivative of y with respect to x. So this equation becomes, this here star becomes what? Y prime is x times v prime plus v is equal to 2 times y over x, which is v, plus 1/2. Okay, and from here, let's move this to the right hand side. We will get x times, you can say dv over dx. This is v prime is equal to v plus 1 over 2. Or you can write instead, so it becomes separable basically, okay? So this is separable now. You start with a homogeneous equation and make it separable. Because you can write this as dv over v plus 1/2 is equal to dx over x. And then you integrate both sides and get the following: ln v plus 1/2 is equal to ln x. Okay. Here it doesn't, well, in general you have ln absolute value of x, but in the question we should assume that x is either positive or negative. X cannot be 0, otherwise the equation is not defined, so you will work in an interval, either the positive side or negative side. Let's work with positive side here. So we have ln x. And this implies basically v plus 1 over 2 is equal to plus a constant, sorry. Some constant c, which is not the same as the previous one. Let's say c tilde times x. Okay. All right, any question with this? We're not done yet. We are looking for y. So from here, v is equal to c tilde x minus 1/2. And remember, v was y over x. So y is equal to x times c tilde, a constant, x minus 1/2. Here c tilde is any real number, okay? It can be any real number. Any question with this? Is it clear at all? Okay, so this C tilde, where does it come from? There is one question like this. Well, you take the exponential here, okay? So take the exponential of both sides, then this is equal to e to the ln x plus c, okay? E to the ln x plus c is what? E to the ln x times e to the c. E to the ln x is x, right? E to the c is another constant now, we call it c tilde, okay? Clear now? Okay, good. Well, let's do another example. Number 4. So determine.
Hocam bir şey sorabilir miyim?
Tabii.
Neden plus c'yi ln fonksiyonunun içine yazıyoruz ki? Yani ln x plus c demiyor muyuz?
İki tarafın şimdi buradan şeyden kurtulmaya çalışıyorum ya. Şurada ln'den.
Evet.
Eşitliğin iki tarafında da iki tarafına da e'yi uyguluyorum. Exponential oluyor. Yani
Evet hocam, tamam, şimdi gördüm.
e üzeri bu eşittir e üzeri bu diyorum, tamam.
Teşekkür ederim.
Tamam. Peki. All right, determine an interval in which solution to the IVP exists. Okay, so without solving the equations, we will find out where the interval, we will find the interval where the solution exists using existence uniqueness theorem, of course. There are two parts here. Let's do this part first. The equation is t times t minus 4 y prime plus y is equal to 0, and the initial value at 2 is equal to 1. Well, you can indeed solve this equation, but we don't need it. We don't need to solve it. Okay, we will find where the solution exists. So let's write this as in the form of first order linear equation. So to make it linear, I will leave this alone, plus 1 over t times t minus 4 plus this is that's it. Here is y is equal to 0, right? Well, you can solve this equation uniquely when this coefficient here is continuous and this is continuous. Well, 0 is a continuous function. It's a constant function, okay? So by existence uniqueness theorem, let's call it star here. Star has a unique solution on any interval containing t is equal to 2, because this is the initial value, and this function, let's call it p here, and let's call it q here, okay? And p, q, containing, and where, maybe let's say where p, q are continuous. And in which p, q are continuous. Okay, so you will find an interval where 2 is an element there, and pt and qt are continuous. P and q are continuous. Q is always continuous. It's 0. P is continuous if t is not 0 and 4. So basically, we are looking for an interval like this. Let's draw this with a picture. We have 2 here. So your interval contains 2. And what are the bad points here? The bad points are when t is equal to 0, 1 over t is not defined. So 0 is a bad point, and 4 is a bad point. At this point, we have discontinuity. So the interval is basically this one, okay? So these are discontinuities of p of t. Thus, let's call it star here. Star has a unique solution. Unique solution on 0 to 4 on this interval. On interval, maybe let's write like that. Okay. Any question with this? Let's do another example. Ln t times y prime plus y is equal to cotangent t, and y2 is equal to 3. Now we will find out where the unique solution exists by existence uniqueness theorem again. So you can write this equation as the following. In the linear form. In the linear form, it becomes like this, is equal to, cotangent is cosine over sine. Let's write it like this, because we will find where this function is not defined, where it is not continuous, and times ln t, okay? So the problem points are here. What are the problem points? This ln t here. First of all, t must be positive, otherwise ln is not defined, right? So t must be positive. It cannot be 0. Ln t cannot be 0. So t cannot be 1, basically, right? So ln t is not 0, which is same as t cannot be 1, okay? If t is equal to 1, 1 over ln t becomes 1 over 0. That doesn't make sense. So function is not continuous, right? But other than that, we don't have any problem with this part. Let's move to the other function here, this one. We have ln t, same conditions. T must be positive. T cannot be 1, otherwise ln t is 0. One more condition for sine t. Sine t cannot be 0. So sine t cannot be 0, otherwise in the denominator we will have 0, which doesn't make sense. Sine t cannot be 0 means what? T cannot be 0, pi, 2 pi, any multiple of pi. So t cannot be k pi for any k integer, okay? 1, 2, -1, -2, and so on. For any integer k, t cannot be k pi, otherwise sine t is 0 and we are in trouble, okay? So these are the conditions for the interval. An interval will contain the initial point, which is 2. So we will have such a picture. 2 is here. So we will find an interval which contains 2 and which avoids all these restrictions. So t must be positive. That means we will start at 0. T is positive. That means we will start at 0. 0 is not included because t is strictly positive. T cannot be 1. 1 is a problem point. So here we have 1. That means we cannot go further than 1 because 1 is problem. Okay. T cannot be k times pi from here. K times pi means we have 0, pi, 2 pi, or negative of those values. So minus pi is here, for instance. That doesn't make a problem because we cannot go even further than 1 to the left, okay? So to the left, we can move that much. To the right, we can move at most pi. Pi is like 3 point, remember, it's like 3.14 and so on, okay? So you cannot go further than that. That means the interval is this, okay? So it is from 1 to pi. So on the interval 0 to, 1 to pi, let's call it star here. Star has a unique solution. Any question with this? Is it clear at all?
Hocam, why did it take the interval between 0 and 1?
Because the initial value here, 2 must be in the interval to guarantee the unique solution, okay?
Okay.
Y2 is equal to 3, so 2 must be in the interval anyway, okay? So in 0, 1, 2 is not included there. Any other question? All right. Let's do one more before the break. That was number 4, number 5. Number. So now here we will consider the Bernoulli equation. Let's maybe briefly talk about this. Bernoulli equations. These are nonlinear, but you can make it linear with an easy substitution. So for instance, think of an equation like this: y prime plus pt y is equal to q of t. If you have this, this is easy. This is nothing but first order linear equation. You can do it with integrating factor. But let's say you have here a nonlinear part, y to the n, okay? Y square, y cube, and so on. Here n is any integer. So this is a nonlinear equation. Nonlinear equation, but change the variable. So what you do here is change the variable. V is equal to y to the 1 minus n, okay? And then this equation becomes a linear equation and you solve it, okay? The star here becomes linear and solved. Let's do one example and see how it works. So let us solve t squared y prime plus 2t y minus or equal to y cube, okay, is equal to y cube. So this is not linear for sure because we have y cube. You can write this in better form, maybe y prime plus 2 over t y is equal to y cube over t square, okay? Now, as we just discussed here, we will substitute this. V is equal to 1, y to the 1 minus n. So do the substitution, say V is equal to y to the 1 minus n. N is here. This is your n, okay? In the Bernoulli equation. This is called the Bernoulli equation, by the way. 1 minus 3. So it is y to the minus 2. Well, let's find v prime and put it, y prime in terms of v prime and put it back into the equation. Let's call it here. This is star. Okay. So what is from here? What is v prime? V prime means we differentiate v with respect to t. It's going to be minus 2 y to the minus 3 times y prime, okay? Well, what you can do is first divide everything by y to the minus 3, so it becomes divide by y cube, and we have y to the minus 3 y prime is equal to 2 over t y to the minus 2, okay, is equal to 1 over t squared. Now you see here, we will use this side and put it back in here, okay? Y to the minus 3 times y. Sorry, there is plus here. Sorry, there's plus here. Y to the minus 3 plus y to the minus 3 times y prime plus, okay, plus 2 over t times y to the minus 2 is equal to this. Okay, so what is this here? This is basically minus 1 over 2 v prime, okay, plus 2 over t v, right, is equal to 1 over t squared, and this is now a first order linear equation. First order linear. And how do you solve this equation? With the integrating factor, right? So basically mu of t is e to the integral 2 dt over t, which is, well, maybe let's first write this in better form. Let's get rid of this minus 1 over 2. So this implies v prime is minus 4. You multiply with minus 2, so it's going to be minus 4 over t v is equal to minus 2 over t squared. Mu of t is e to the minus 4 over t dt. Okay, and this is e to the minus 4 ln t, so t to the minus 4. Okay, so this implies t to the minus 4 times v is equal to minus 2 t to the minus 6. Okay, and from here t to the minus 4 times v is equal to, the integral here is minus 2 t to the minus 5 over minus 5 plus a constant. And remember, v was what? Y to the minus 2. So this was y to the minus 2. And you can obtain y from here, right? This implies 1 over y squared is equal to 2 t to the minus 1 over 5 plus c times t to the 4. Or you can say, maybe let's leave it here. It's enough to leave it like this. Since we don't know whether y is positive or negative, we don't have initial value here. You cannot write the explicit solution. You can leave it like this, okay? Any question with this? All right, let's give a break here for 10 minutes. So let's continue at 9:45.
Hocam,
Evet.
bu Bernoulli equation'ın normal lecture'ları işlerken görmüş müydük yoksa şu an ilk defa mı anlattınız?
Yok, şu an ilk defa gösteriyoruz. Ama yeni bir şey değil. Bu zaten değil mi? Değişken değiştirip first order denklem çözüyoruz yani. O yüzden yeni bir konu değil yani.
Tamamdır hocam.
Ya, Bernoulli'den de sorumlu olacak mıyız hocam?
Tabii yani yeni bir farklı bir konu değil bu yani. First order içinde anlatılan bir şey. Dolayısıyla sorumlusunuz. Yani buna kitapta bakarsanız buna exercise olarak veriyor. Yani bir konu olarak anlatılmıyor bu. Yeni bir konu değil. Peki. Var mı başka sorunuz? O zaman ara veriyoruz. All right, welcome back. Let's continue. Well, let's look at this example. Y e to the 2xy plus x dx plus b times x e to the 2xy dy is equal to 0. And the question is find b that makes star, this is star, exact. All right, well, so we want to make this exact. Let's say this is m and this is n. Okay, for an exact equation, we need m sub y must be equal to n sub x, right? What is m sub y? M sub y is basically y times e to the 2x y times 2x. We use the product rule here. Okay. Plus e to the 2x y. And n sub x is b times, take b out, e to the 2xy plus x times e to the 2xy times 2y. Okay. Well, if they are same, here b must be 1, right? Because you see from here this one and this is same as that one, the whole thing here. So this implies b is equal to 1.
Hocam, while we were taking the derivative, why did we write plus uz e times 2 times xy?
It is a derivative of this function m with respect to y. So we take the derivative of this here with respect to y. Derivative of this with respect to y, we have a product, right? Product, we use product rule. The first function y times the second function, derivative of the second function, which is this.
Yes, okay hocam, okay.
Okay, with respect to y. Okay. So that's it. Any question with this? So if b is equal to 1 here, it's an exact equation. Let's do another example. So let us solve nine x squared plus y minus 1 dx minus 4 y minus x dy is equal to 0, and y1 is equal to 0. Okay, well, you can easily see that this is an exact equation. If I say, for instance, this is m and this is n, so m sub y, which is 1, is equal to n sub x. So this implies star here, star is exact. Since it is exact, we can find the solution easily. So find f depends on two variables, x and y, such that f sub x will be, derivative of f with respect to x will be 9x squared plus y minus 1, and f sub y will be minus 4y plus x. You can start with either. The easier, sometimes one is easier than the other one to integrate. Here, both are easy to deal with. Maybe this is even easier to work with. So I will start with this one. So I will integrate with respect to y. So f xy will be what? Minus 2 y squared plus x times y plus a function of x, right? And using this, I will differentiate with respect to x, and this is equal to, from here, you differentiate this with respect to x. So you get what? You get basically y plus h prime x, okay? Which implies h prime x is equal to 9x squared minus 1. (9x squared minus 1). And this tells you Ajax is equal to maybe. Let's continue here. So Ajax is 3x cubed minus x plus a constant. So let's put this back in f, and f becomes minus 2 y squared plus xy plus 3x squared minus x plus c is equal to 0. is the solution, is the general solution, because C is an arbitrary real number here. Is the arbitrary solution, a general solution, let's say. General solution
X küp olacak
to
galiba.
star. Soru mu var?
Hocam genel solution 3x kare yazdığınız zaman o 3x küp mü olacak?
Ha, pardon, evet, şuraya geçirirken evet, var mı soru arkadaşlar?
Hocam bir şey sorabilir miyim?
Tabii.
Bazı soruların çözümlerinde direkt C'ye eşitliyorlar da öyle olmasının sebebi C'nin bir tam sayı olması mı?
Yok, C tam sayı değil, C reel sayı. Tam yani rasyonel olabilir, irrasyonel olabilir. Bunu C'ye de eşitleyebiliriz. Yani C başka bir C olacak tabii o zaman. Ama bunu bu tarafa attığın zaman yine o da bir sabit.
Hani ama eksi C olarak gidiyor ya hocam. O kafamı karıştırıyor.
Ama tabii eksi C olacak, eşittir eksi C. Ama şimdi C herhangi bir reel sayı olduğu için eksi C de herhangi bir reel sayı. Yani aynı family'yi veriyor bunlar. Öyle düşün.
Anladım. Yani bizim C'miz aslında oradaki C değil. Yani bir K değeri gibi. Öyle mi?
C herhangi bir sabit sayı.
Tamam.
Yani dolayısıyla sen C'yi buraya da koysan, buraya da koysan fark etmez. Çünkü buraya koy, mesela bu C'nin içinde ne var? Bu C mesela eksi 3 olabilir. Eksi 3 olursa bu mesela C, o zaman bu tarafa attığın zaman artı 3 olacak. Ya da işte artı 3 olursa bu tarafa attığın zaman eksi 3 olacak. Yani bir tarafa C yazmakla öbür tarafa eksi C yazmak arasında bir fark yok. Ya da yani o artı eksinin hiçbir önemi yok çünkü tüm sabitler üzerinden tanımlıyorsun çözümü.
Tamam hocam. Teşekkür ederim.
Hı hı. Any other question? Okay. Let's do a linear system example. Number 8. Page here. Well, the question, let's start with linear independence first. Are the followings. Vectors, let's say, linearly independent. Let's start with this. So we have vector functions x1t, which is 2 sine t, and x2t, sine t, 2 sine t. Well, we check the Wronskian of this. The Wronskian will be 2 sine t, 2 sine t, and this is nothing but 3 sine square t. And remember, if the Wronskian is not zero even at one point, then you say these are linearly independent. And here, this is not zero. Okay, let's see here. Thus, we, for instance, at pi over 2, if the Wronskian is non-zero at one point, since this is 3 times 1, which is non-zero, right? X1, X2 are linearly independent, okay? Right, we did this in class. If the Wronskian is non-zero at some point in the domain, then you have linearly independent vectors. Is that clear?
Hocam,
Evet.
vektörlerin ya da fonksiyonların linearly independent olduğunu bilmek bizim ne işimize yarıyor? Bu neden önemli?
Ne işimize mi yarıyor?
Tam anlatamadım ama
Yani bu şu demek, bu vektörü diğer vektör cinsinden yazamıyorsun demek. Yani bu vektör şunun bir katı değil demek, tamam mı? Bu da ne işine yarıyor? Çözüm bulurken, değil mi? Lineer sistemlere çözüm bulurken linearly independent çözümlerin varsa bunlar basis oluşturuyor. Yani basis ne demek? Herhangi bir çözümü, senin diyelim 2'ye 2 matrisin var, 2'ye 2 sistemin var. Bunlar da çözümlerin. Bunlar linear independent olduğu için herhangi bir çözümü bunların lineer kombinasyonu olarak yazabilirsin. Bunu söylüyor mesela.
tamamdır hocam.
Tamam. Tek değer vermemiz yeterli mi diye sormuşsun Buse. Yani sıfır dışında bir değer elde edebiliyorsan o tek değerle yeterli. Yani bu çünkü şu demek. Şimdi biz bunların linear independence'ı nasıl check ediyoruz? C1, X1, T artı C2, X2T eşittir 0. Bunu kabul ediyoruz. Bu her T için. For all T. Bu her T için doğru. Özel olarak da pi bölü 2 için de doğru. Pi bölü 2 koyduğumuz zaman evet, T is equal to pi over 2. Bu Wronskian sıfırdan farklı çıktığı için bize neyi verdi bu? C1 eşittir, C2 eşittir 0 verdi. Bizim amacımız zaten bunu göstermekti. Yani C1 eşittir, C2 eşittir 0'ı elde edebiliyorsan o zaman bu vektörler linear independent oluyor. Ama mesela buna 0 noktasında bakarsan o da 0'a eşit ama o bir şey söylemiyor. Tamam. Yani bir noktada 0'a eşit olabilir. O bir şey söylemiyor. Ama sıfıra eşit olmadığı bir nokta varsa o zaman linear independent diyebiliriz. Bu argümandan. Belki bunu da şöyle bırakalım. Linearly independent. Linearly independent demek bir vektörü diğerleri cinsinden yazamıyorsun. Burada iki vektör var zaten. Yani burada x1'i x2 cinsinden, yani x2'nin katı olarak, herhangi bir katı olarak yazamazsınız. Bunu söylüyor. Any other question? Okay, let's do one more example with this type. A, B here. So the vectors are now we have constant vectors, x1, 2, 1, 0, x2, 0, 1, 0, x3, -1, 2, 0. Bunlar linearly independent diye bakıyoruz. Are these linearly independent? Since these are constant vectors, again we check the Wronskian. Wronskian is either identically 0 or different from 0. If the Wronskian is 0, they are linearly dependent. Otherwise, they are linearly independent. So V here is basically the determinant 2, 1, 0, 0, 1, 0, minus 1, 2, 0. Which is 0, right? Because we have a 0 row here. So if you expand the determinant with this row, this determinant will be 0. This implies x1, x2, x3 are linearly dependent. This says basically you can write, for instance, x1 as a combination of x2 and x3. It's possible. And even we can try, for instance, maybe we're done here basically, but let me try to write, for instance, x1 here as a combination of the other two. So to obtain x1, we will multiply x3 with minus 2 times x3. So you get 2 there, minus 4 plus, I guess that's 5 times x2, okay? You see here. So basically you can write any vector in terms of other two here by this equation. So this implies, if you do that, if you were to find this equation at the beginning, you can say that they are linearly dependent without looking at the Wronskian. But Wronskian is a more systematic way to get the answer here, okay? So this is another way to explain why they are linearly dependent. Any question? Is it clear? Açık mı bu arkadaşlar? Lineer bağımlı, lineer bağımsız. Lineer dependent demek herhangi bir vektörü diğerleri cinsinden, diğerlerinin kombinasyonu olarak yazabiliyorsanız buna lineer dependent diyoruz. Mesela burada yazabildik. Bunu yazmamıza gerek yoktu. Zaten Wronskian onu söylüyordu. Ama açıkça da yazdık, gördük. Üstteki örnekte mesela Wronskian bir noktada sıfırdan farklı çıkması yeterli. Linearly independent demek. Burada bunu yapamazsınız. Mesela burada x1, x2 cinsinden yazamazsınız. Okay, there's one question. How do we get here 0 Wronskian? Well, this determinant, you can expand determinant with any row you want. Here, you can expand this, for instance, this is plus, minus, plus, okay? So 0 times the remaining matrix, 0, minus 1, 1, 2. You don't need to write this because 0 times something is 0, okay? Minus 0 times something, plus 0 times something, okay? So the result will be 0, okay? That's why we choose, when we expand the determinant, we choose the columns or rows with more zeros, okay? Because it's easier when you have 0, you have basically nothing, right, from that entry. Okay, good. Any other question, comment?
Hocam bir şey soracağım.
Sor.
Eğer üçüncü x3 olmasaydı 3'e 2 matriksimiz olacaktı. O zaman nasıl Wronskian alacaktık?
O zaman Wronskian alamazsın. Elle check etmen lazım. Yani işte C1 çarpı X1, C2 çarpı X2 deyip oradan C1, C2'nin 0 olduğunu göstermen lazım. Güzel soru.
Tamam. Teşekkürler.
Yani eğer kare matrisi elde edemiyorsan o zaman tanımdan gidip yapman lazım. Başka yolları da var tabii. İşte biraz lineer cebir biliyorsan renkine bakıyorsun falan. Ama biz çok bu derste lineer cebir kullanmıyoruz o kadar. Yani kullanıyoruz ama işimize yarayacak kadar. O yüzden o renk hesabı falan burada yapmıyoruz. Ama onun da yolları var. Daha sistematik de yapılıyor. Yani bu şeyden mesela şu ikisine baksaydık. So if you think of this two, for instance, these are linearly independent. Maybe let's try this, okay? Let's do this as a third part, C. Let's take this two vectors, 2, 1, 0. Okay, this is x1. And the other is 0, 1, 2. Zero, 1, 0, sorry, 0, 1, 0. Let's check out the linear independence of these two. We cannot check the Wronskian because it is not a square matrix. We cannot talk about the determinant, but let's try this. So suppose that C1 x1 plus C2 x2 is equal to 0. This implies what? This implies basically C1 times 2, 1, 0 plus C2 times 0, 1, 0 is equal to the 0 vector, which implies 2C1 plus 0C2, which is 0, is equal to 0, and C1 plus C2 is equal to 0. The last row will give you 0 is equal to 0. So from this, C1 and C2 are 0, right? C1 is equal to C2 is equal to 0, which implies x1 and x2 are linearly independent. Okay. Any question? All right, let's do a final example. Okay, that was number 8, number 9. Let us solve the initial value problem. X prime is equal to 5 minus 1, 3, 1. This system, x, so x is the vector. The initial value is x0 is equal to 2 minus 1, okay? Well, to solve this, we find the eigenvalues, right? And eigenvectors then. What are the eigenvalues? 5 minus lambda minus 1, 3, 1 minus lambda. Remember, what is an eigenvalue? Eigenvalue is A times, this is A here, matrix. A times V is equal to lambda V. So this is the eigenvalue, okay? So we will find this. And to find this eigenvalue, well, maybe let's also write here. This is eigenvalue, and V here is eigenvector, okay? It's non-zero, of course. Well, 1 minus lambda. To find eigenvalue, we look at this determinant, right? And it becomes lambda minus 5 times lambda minus 1 plus 3. And this is nothing but lambda square minus 6 lambda plus 8 is equal to 0, minus 4 minus 2. So lambda is equal to 2 and 4. Lambda is equal to 2. Let's start with this. This is an eigenvalue, and we will find the eigenvector now. Eigenvector. For lambda is equal to 2, we have 3 minus 1, 3 minus 1. V1, V2. V times V1, V2. Or maybe we don't even need to write this. Let's put here 0, 0 and solve this system. This tells you basically we have subtract the first row from the second one, 3 minus 1, 0, 0, 0, 0, right? This is R2 minus R1 goes to R2. So this tells you we have one free variable, and this implies 3v1 minus v2 is equal to 0. Okay. Let's say v2 is free, so we get basically v2 is k, which is non-zero, let's say. So the eigenvector is k times v1 is v2 over 3, 1 over 3, and 1. So these are eigenvectors, and the solution and one solution, let's say. Let's call it star here. E to the lambda t, lambda is 2, times an eigenvector corresponding to 2, which is 1 over 3 and 1. Okay, so this is a solution, and we will get another solution like this, and then a combination will give you the general solution. So lambda is equal to what is the other one? 4. For 4, we have 5 minus 4, which is 1, minus 1, 3, minus 3. Well, again, this is basically 1 minus 1, 0, 0, 0. And from here, v1 minus v2 is equal to 0. Let's say v2 is k. Let's use another letter, L. Let's say L, okay, is non-zero, a free variable. This is free. So the solution is simply v1 is equal to v2 and eigenvector L times 1, 1. And the solution, another solution to start, e to the 40 times 1, 1. Well, the general solution is you don't need to check the linear independence here because we have different eigenvalues. And remember, when we have different eigenvalues, the corresponding solutions are different, linearly independent. Okay, so that's the general solution. Xt is equal to C1 e to the 2t 1 over t1 plus C2 Maybe let's write this first. 1, 1. This is the general solution, but we had an initial value problem. At 0, we had this vector 2 minus 1. Okay, so we had this initial condition. Using this initial condition, we can find the coefficients here, C1 and C2, IVP. Remember, x0 is 2 minus 1. And at the same time, x0 is from here. We have what? C1 times e to the 0 is 1. 1/3, 1, plus C2, 1, 1. And from this, you can find a C1 and C2. Let me do this in a fancy way. Well, you can do this by hand, but we can also do this with matrices. This is nothing but 1/3, 1, 1, 1, C1, C2, okay? Say this is now, by the way, you don't have to do it like this. You can find C1 and C2 like you do in high school or in elementary school, if you like. Say this is B, okay? What is B inverse? The inverse of this matrix, 1 over the determinant, which is 1/3 minus 1. And remember, you switch the orders here, 1, 1/3 when you find the inverse, and minus 1, 1, right? Minus 1. Yeah, so this is what? Minus 2/3 minus 3/2. One minus 1 minus 1, 1/3. And C1, C2 becomes what? It's basically B inverse times 2 minus 1. So we use this here and this, okay? So take B to the other side, this side, and we have this one. And this is nothing but minus 3/2. 1 minus 1 minus 1, 1/3 times 2 minus 1, which is minus 3/3, 2. This is 3 minus 2 minus 1/3. So basically minus 9/2. This is C1, okay? And this is 7/3, 7/2. Okay, So basically the solution is x of t is C1, which is minus 9 over, so this is C1, and this is C2. Minus 9 over 2 e to the 2t 1 over 3, 1. And C2 is 7 over 2 e to the 4t. It's 1, 1, right? 1, 1. So this is the solution of the initial value problem. Okay. Any question with this? Var mı soru arkadaşlar? Tabii ki bu C1, C2'yi daha kolay bulabilirdiniz. Ben sadece burada bir de ters matris kullanıp bulmayı gösterdim. Yani farklı bir yöntem olacak ama elle yapmak daha kolay. Question, comment? Bu niye eigenvektörü bulduktan sonra bununla çarptık? Çünkü şeyi biliyoruz değil mi? Genel çözüm bu formdaydı. Denklemin çözümü her zaman işte e üzeri lambda t çarpı eigenvektör değil mi? Yani e üzeri lambda t çarpı v. Bu bir çözüm oluyordu denkleme. Onu göstermiştik sınıfta neden olduğunu. Notlarda var. Question, comment?
Hocam 1 bölü 3'e bir değerini 1'e 3 olarak yazsak sıkıntı olur mu?
Olmaz. Aynısı. Onun 3 katı.
Öyle yaptığım zaman hocam C1'i ben eksi 3 bölü 2 buldum ama farklı oluyor.
Çünkü o da onun 3'te 1'i.
Sıkıntı olmaz ama değil mi hocam?
Yani aynı şey olmuyor mu? Bir tarafı 3 ile çarpıyorsun, diğer tarafı 3'e bölüyorsun. Dolayısıyla bunlar
Doğru. Doğru hocam, pardon. Teşekkürler.
Tamam. Any other question? Güzel. Yani o zaman en azından işlem hatası yapmamışız. Onu gördük. Aynı sonucu bulduğumuza göre. Question, comment?
Hocam, bu son kısımda çözümü direkt C1 bölü 3 artı C2 eşittir 2, C1 artı C2 eşittir 1 yazıp evaluate edip de bulabiliriz değil mi?
Bulabiliriz tabii onu söyledim yani. C1, C2'yi her türlü bulursun.
Tamamdır hocam, sağ olun.
Bu biraz böyle şey oldu. Matris kullanıp da nasıl bulabiliriz? Yani mesela bu daha karmaşık denklemleri böyle yapabilirsiniz ama bunda çok gerek yok. Peki o zaman burada bitirelim. Let's stop here. Good luck with the exam on Saturday. Your exam will start at 5 p.m. but you should be ready half an hour earlier than 5, right? Read the instructions carefully before the exam. And fill out the KVKK form. KVKK formunu doldurmadıysanız doldurun. Doldurmazsanız sınava giremezsiniz. Önemli. Halen açık bildiğim kadarıyla.
Hocam,
Evet.
sözünüzü kesmiyorsam sonuncu soruyla alakalı bir şey sorabilir miyim?
Sor.
Tersinden nasıl gittik? Ben o kısmı
Şimdi-
yani onun genel soru şey neydi?
Evet.
Genel
Genel olarak
equation.
şöyle düşün. Şimdi mesela diyelim şöyle bir denklemim var. İşte nasıl bir şeydi o? Şurada bir matris var. A çarpı C1, C2 eşittir. Sol tarafta da bir vektör var. İşte 2'ye eksi 1 falan var değil mi? Böyle bir şeydi. Şimdi buradan C1, C2'yi bulacaksın. Da örneğimizde uyumlu olsun. Bu B matrisi dedik buna. B matrisi. B matrisi çarpı bu. Buna eşit. O zaman C1, C2'yi bulmak için B'nin tersini bulursan ve iki tarafı da B'nin tersi de çarparsan.
Identity mi oluyor?
Evet.
Doğru. Tamam, evet. Aynen.
Identity oluyor ama o identity ile bir şey çarpmak yine
Aynen.
C1, C2. Tamam.
Tamam, doğru. Teşekkür ederim.
Any other question? All right. Good luck with the exam. See you. Bye.
Teşekkürler hocam.